Hi there, welcome to another EMT 1100 video. In this video, we'll be looking at what is differentiation, what we mean by differentiation by first principles, and finally the different types of questions you could get in an exam based on using first principles. So let's go. Okay, to get straight to the point, the derivative of a function is basically the gradient of the function at a point. Or let's say the gradient for now. Okay, so we have here, we know the gradient of a function. M is simply y2 minus y1 over x2 minus x1. This is the definition of gradient we know from since secondary school. Alright, let's call this function y is equal to 2x. Now, this is normally labeled x2 and y2, and this is normally labeled x1 and y1. Now, why is this always 2 subscript and it's always 1 subscript? Because what we really do is choose this value first. We really do is find an x. Anytime you're developing a function, you always choose the x value, any x value, and then see what the corresponding y value would be based on the definition of the function. Right? So just say choose any x value, or okay, x equal 4. So if x is 4 at this point, for the x squared, and then the y value for this graph will be 2 times 4, which is 8. Right? And then if you choose the next one, 9, this will be the matching 9 would be 18. 2 times 9. Right? Now, what you really do, it's not just, you don't state it as 2 random points, you just choose. You choose this point and call it x, and then say you increase the chosen x value by something called delta x or h. I will be using h for this video. I'll tell you why. So the increase in x, I will call it h. Alright? So now we can redo this graph now. Right? So we call the gradient, this is a y equal 2x graph, right? The gradient again is y2 minus y1 over x2 minus x1. Now, look at this. If we know that this x2, it is just this x1 plus whatever increase you want to give it to get the second point. Alright, remember it's 2 points. I say we always choose an x to 1 point. For this example, increase it by 5. So this our 9 was the second x, and we derive the second y. Good. So how are we going to write it using this? We will write in this equation, x2 minus x1. The first x1 we just call x because the x we chose. This next x, it is the first x plus whatever increase we decide to give the x. So this is now x2 minus x1. y1, well, y1 is 2x. y is 2x. So whatever is the first x, if x is 4, as I get, it's just 2 times 4, 8. So y1 is just 2 times x. So just 2 times the first x. y2, on the other hand, it is still 2 times x, but this time the x is a little bit bigger. So the y2 is still 2 times x, but this time the x is just x plus h. It is still an x value, but just a higher x value because the h represents the small increase in x. As simple as that. Comprehend? Okay, so now let us consider some rules with gradients. You can only find the gradient of a straight line, and if you pick any 2 points, if you pick some x, you got to get a y, increase the x by x some value, and you pick this point, this gradient should give you the exact value as if it chosen a smaller interval or a big interval. Doesn't matter. It's supposed to always get the same gradient. And as I said just now, you can only find the gradient of a straight line. Alright? Alright, before we go on, just look at this. Look at this one more time. This is the gradient of the straight line. The bottom, the denominator, will always remain the same no matter what function we get. But the numerator will change. But for instance, this is 2 times this because the function is 2 times x. And this 2x is the function of itself. At the denominator, there will always be an x2 minus x1, which is the first x being x1 and second x being whatever x you chose plus the increase. So when you work out this, at the bottom, you always get x plus h minus x. So this and this would always cancel out, because it's just x plus the increase in x minus x. Only the increase will leave back. So you can rewrite this formula for now. All over h. Alright, so this is still the gradient formula. This is still this. The difference in x is just h. And well, this, I can do a general thing for this. I wouldn't do it as yet. 6 minutes. Okay, now consider what I said just now. You can only find the gradient of a straight line. So, if we have a circle, could we find the gradient of that circle? No, because there's no 2 points I could choose that would be in. There's no, if I choose this point and then increase x by some other, this and this is not a straight line from here to here. It is a curve. Matter of fact, any 2 points on this circle, it would always be a curve in between them. So how can I ever find a gradient of any part of the circle? Think of this. If I investigate one point, if I zoom into this point close enough, like I take a microscope and I really zoom in really much, zoom, right? Then in this point, it will still look like a straight line. You magnify this point, and it still looks like a straight line. Of course, the point will look really very, very, very thick, but the line could just, if it look it just take over the whole page, look very thick. But if we decrease the thickness to just a strip, then it will still look like a straight line. So if you magnify any point enough, you will get a straight line. Remember, this whole straight line is just within this point magnified. Alright, so we can actually find the gradient of this point, because this point is actually a straight line when you magnify it. No, but so if we're going to choose the x, when we're doing the increase, to choose the x and we get a y, to get, remember, m is equal to y2 minus y1 over x2 minus x1. So we chose our first x, choose our first x to get a y. Now we choose our second x. The difference between our first and our second x, the h, or delta x, needs to be very, very, very small, because you can't increase this x by much if you want to stay in this straight line, because we're operating really inside a dot. So your delta x, the difference in x or your h, gotta be really, really, really small, because if you choose any big value, you would come out of the dot. You're in a microscopic dot. So the increase in x has to be also microscopic. The h, or the increase in x, has to be microscopic. This has to be very small, like 500 zeros and then 1. So we need to really find them. You're still finding for the circle the gradient at this point consider a straight line. We still apply this formula, which is this, except this h, this increase in x, has to be really, 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 really small. Now that's why to find it, you do the formula, but to find the answer is the limit of this function. Do I have space? The limit of this function as h approaches 0. Sorry for the squeeze. Because h needs to be very, very small. The increase x needs to be very, very small. Almost 0. Remember, it can't be 0. If the increase is 0, then it didn't actually move at all. Alright? So just the increase must be heading towards 0, almost 0. Alright? So to find this gradient, this m is equal to the limit as the increase in x, which is h, goes to 0 of whatever is y2 minus y1 over h, over h, increase in x. So let us do an example. Oh, now when you're finding the gradient of a function, when the increase in x is almost 0, that's when you call the gradient a derivative or differentiation. This is when you're doing differentiation. It's still a gradient, but a gradient that is restricted to a delta x that is delta x or an h that is very, very, very small. So let us do the example. Let's see, we have a curve, call it y is equal to x squared. Right? Now, again, there's no 2 points on this curve you could choose that would be following a straight line, because the whole thing is a curve. So you can only find a gradient at a particular point on the curve. So you look at a point and you zoom in on, and it looks like a straight line. So to find a gradient of this point, to find a gradient of this point is basically find the derivative of the graph. So when we do this, since I'm saying that this is differentiation, when you find the gradient when h is almost 0, then when I find a gradient at any point, when I find a gradient of this curve within any dot using this, then I'm saying I am actually finding the derivative of the curve using this gradient formula. So, well, you guys already know that if you have x squared, if y is equal to x squared, then if you differentiate the y, you get 2x. You know this. So if I'm saying the gradient is the derivative, then when I find a gradient at a point of this function, I'm supposed to get 2x. So we go. We say m is equal to the limit of h goes to 0. No. Okay, let's say y2 minus y1 over h. Alright, put back the h. Now, the first y value will just be whatever was the first x value we chose in this function. So the first x value was 3, just be y equal to 3 squared, 9. So the first y value, just write back the exact function. Y is equal to x squared. This is what the name of the graph is. Y is equal to x squared. Now, this is our y1. Our y2 will still be y equal to x squared. Right? But this and the x squared will be, the x will be a little bigger. It is still x squared, but the x is of a slightly higher value this time. Right? So you still have y2 minus y1, Remember our first y is just x squared because this is the graph, y x squared. And the second y2 is also x squared, but the x is a little bit bigger by the increase you gave it. Choose the x. Increase it, plus a little bigger x, and you get it. Oh, low battery. Alright, good. So let's solve this. With limits you plug in, just plug in this value for the value for h, 0 in here. If we do it now, we get 0, 0. So we get x squared minus x squared. We get 0 over 0. Alright, so we know 0 over 0 can't work, so we factor out this minus this. So basically we gotta factor the h minus 0, just h. Alright, so let's see. We'll expand this first and see if we can factor out the h. So this is x squared plus 2xh plus h squared minus x squared over h. This will cancel out with that, and we have this remaining, and then we factor out the h because we wanted to factor out an h. You write the h. What you gotta multiply the h right to get back this? 2x plus h squared all over h. And this goes up with that, and then we can put in the 0 there. So when we put in the 0, just 2x plus 0 remains. So the answer is just 2x. So guess what? We proved using a simple gradient equation, but we restricted the h to almost 0, and we got 2x. Which you got this when you do the general rule for differentiation. Now, this is what it's using first principle. The first person that did it this way first and got this answer, and then they realized that hey, I could have just multiplied this by the power and decreased the power by 1. So the first principle is this way of doing it, of finding the derivative, getting to x, and then this is a shortcut that came from the first principle. So if you see your first principles questions, this is what you have to do. Now, a next type of question that could come is we have to use first principles is in finding the equation of the tangent of a line that passes through a particular point. Now, think of this. We're investigating this point. If I have a very long straight line, if I pass a straight line through this point, alright, let's see, I just passed exactly there just to touch, pretend this is a straight line, and it touches the exact point. Then at a microscopic level, remember this point is this line, then this line would pass directly through this point. So if I want to know the gradient of a line that passes through this point, right, this point, I don't have to find the gradient at this point, and that will be the gradient of the line, because the line is in line with the line, which is the what? The expansion of this dot. I hope you guys understand what I mean. I'm sure you do. Right? So the question might ask, find the equation of the line that passes through this point at, let's just say x is equal to, let's just call it 4 or something. Right? Alright, important thing to know about gradients of tangents. Let's go back to the circle. If I choose a point, this point, if I put a tangent at that point, the slope would be, this is practically 90 degrees, right? At this point, I'll get a slope like this. Coming down here, I'll get a slope like this. I'll get a slope like this. So at any point, the slope would keep being different all the time. depends on what value of x you get. This is the graph. Depending on what value of x you chose for the along here, if x is this, and you go up and touch here, the tangents at this point will be aligned, looking something like this. If you choose x at this level, you go up, and the tangent at this point will be almost a straight line. So the tangent at every point would have a different gradient. It would have a curve would give an exact, a particular gradient equation. Like for instance, this y square curve. When you do the derivative, you see the gradient equation is 2x. So you can see m is equal to 2x. That is the gradient, but the actual number for the gradient would change according to what value of x that I showed in the circle. For this, when x is equal to 3, the gradient will be 2 times 3. So the gradient will be 6. At different value of x, we have different gradients. So remember, the gradient is just a number, which is the ratio of the difference in y's over the difference in x. So gradient is just a number, and it changes for whatever value x you put. Alright, so let's go back to the same question. Except this time, no, the same graph. Except this time we change the question. Alright. They might just ask, okay, write the equation of a tangent line that passes through tangent line of this curve that passes through x is equal to 4. Alright. Now a tangent is a straight line, so the curve needs to look like y equal to mx plus c. Right? So now before you turn it into this form, when you first write a general y minus the given y is equal to m, the general x, minus the given x. Right? This is an asterisk. The given x is the x value that you're asked to find the tangent at, and the given y is the x value that corresponds. Sorry, the given y is a y value that corresponds with the x value. Now they might just tell you y is equal to something. They might actually give you the y, or they might just tell you the x. But to find the y, you just plug it in here. So y is equal to x squared, which is 4 squared. So the y is equal to 16. Alright? So you're going to find the the equation of a tangent line that passes through 4. Alright? So we just do this. And we rearrange, and this is pretty easy. So let us see. Alright, y minus, what's this given thing? 16. Y minus 16 is equal to m x minus 4. Right? Now y equal mx plus c. This y and the x always remains as variable, but we gotta find a number for the m. So we gotta find a number for this m, and as I said, m is simply the gradient. And we did find the gradient equation of this x squared by doing this. Remember, this was x squared. And we do this, and we find the gradient equation for x squared is 2x. Right? So m is 2x. But what is the gradient at x equals 4? Because the specific number changes with the x. It's a general gradient equation. So at x equals 4, we have the gradient is equal to 2 times 4, which is equal to 8. Correct? So y equal to 16 is equal to 8x minus 4. Now we just turn this into y equal to x plus c form. So we have y is equal to 8x minus 32 plus 16. So y is equal to 8x minus 16. Y is equal to mx plus c. So we have successfully found the equation of the tangent line that passes through the point x is equal to 4. Right? This, you will always follow this for every tangent line question. It will always be those exact steps you will have to follow. Okay, now of course you could have known the m by just doing the general rule for differentiation. Just know that, okay, differentiate x squared, just get 2x, and then just go here and let's do 2 times 4 is 8. But if you have a tangent line problem, you will have to show the m using first principles. Any tangent line, the teacher would ask first principles. If you have a tangent line and the teacher does not ask the first principles, then I guess you're safe and you got off. But most likely you have to do first principles. Okay, that's enough. This video I showed you what is differentiation, the definition of differentiation, and we proved one first principles question, and then we did the equation of a tangent line, and that covers every type of question. The next video we'll do the homework. Bye bye.